Hello, my dear student. Today I am going to discuss about IGCSE O-Level Certificate in Physics. Chapter Solids, Liquids and Gases. Let's start from the beginning. First we have to learn about what is matter. What is matter? Anything that occupies space and have mass and made of tiny particle is called mass. So the things which have mass occupies occupies some space, and if we apply force on it, if we apply force on it, then it resists. Then it resists. Then that thing is known as matter. It includes everything around us: the food we eat, the water we drink, the air we breathe, the aircraft we fly, as well as the atmosphere. Conservation of matter. Matter cannot be created or destroyed, but is able to change its form with release of energy. So energy cannot be created or destroyed. We can convert it from one form to another form, or we can able to change its form with release of energy. Now, states of matter. Matter is anything that takes up space and has mass. It occurs in three states: solid, liquid and gas. Solid. Solid has definite shape. So solid has definite shape and definite volume. Here the particles are in tight and regular pattern. So closely packed and regular pattern. The particles are close together and vibrate. A solid does not take the shape of the container in which it is placed. There are two types of solid. One is crystalline, where particles are orderly, 3D arrangement of the particle. Amorphous, the particles are in no particular order. Amorphous. Now liquid, definite volume but no definite shape. Particles slide past each other to take the shape of the container. So particles are farther apart and can move freely. So in liquid, particles are farther apart and can move freely. Gas, no definite shape, no definite volume. The particles in gas are much farther apart than those in liquid or solid. Gas particles move at high speed in all directions. Plasma. Plasma is the ionized gas. So where one type of particle are mobile and another type particle is stationary comparatively. No definite shape, no definite volume. Particles move freely in all directions, smashing into each other, breaking particles apart. Example in nature: lightning, aurora borealis. So substance can exist as solid, liquid and gases. In solid, the particles or molecules vibrate about fixed position within a close packed regular structure. The particle cannot move in between each other, which result in solid have a definite shape and fixed volume. Liquid. Number two, liquid. When solid is heated, it may melt to form a liquid. In a liquid, the particles or molecules move in between each other and are approximately the same distance apart as in solid. A liquid does not have a definite shape, but it does have a fixed volume. So remember, liquid does not have a definite shape, but it does have the fixed volume. While liquid has no definite shape, liquid matter has a fixed volume, which means it takes up the space. Liquid does not have fixed shape. They take the shape of their container. Liquid can flow, be poured and spilled. Gases. When liquid is heated, it may evaporate or boil to form a gas. In a gas particle, molecules move in between each other and are much further apart they are in a liquid. So in gas molecules, they are free to move. They are moves in random way. Gas takes up the space of the shape and volume of the container. Property summary table. Property definite shape, solid yes, liquid no, gas no. So liquid and gas no definite shape, can be easily compressed. Solid no, liquid no, gas yes, because there are a lot of space between particles. Relative density, solid high, liquid also high, gases low. Can flow, solid no, liquid yes, gases yes. Expands to fill container, solid no, liquid no, gas yes. Fixed volume, solid yes, liquid yes, gases no. Because gas has no intermolecular attraction force, so it occupies all space of the container. So particle arrangement in phases of matter. Solid particles are packed tightly together in a fixed arrangement. Particles can vibrate but not move. In liquid, particles are close together with no distinct arrangement. Particles can move and slide around each other. Gases, particles are free floating with no distinct arrangement. Particles move, collide with each other. Physical state, increasing energy. Solid, the molecules that make up the solid are arranged in a regular repeating pattern. They are held firmly in place but can vibrate within a limited area. Liquid, the molecules that make up the liquid flow easily around one another. They are kept from flying apart by attractive forces between them. Liquid assume the shape of their container. Gas, the molecules that make up the molecules that make up a gas fly in all directions at great speeds. They are so far apart that the attractive forces between them are insignificant. Plasma. Plasma, at the very high temperature of the stars, atoms lose their electrons, and the mixture of electrons and nuclei that result is the plasma state of matter. Plasma is the ionizing state of gas, where one type charge is mobile and another charge is stationary relatively. This is a summary of solid, liquid, and gas. In solid, strong attraction between the particles. Uh, Liquid, moderate attraction between the particles. Like in gas, very weak attraction between the particles. The attraction, intermolecular attraction force between gas particles, negligible. Particles are very close together and neatly arranged. In solid, particles is still very close together but not neatly arranged in liquid. Particles are much further away from each other in gases. So in solid, particles vibrate in within a fixed place. Particles are able to slide past each other in liquid. the particle move all around and bumped into each other in a random way in gas. So solid has definite shape and volume, liquid in definite shape and definite volume, gas indefinite shape and indefinite volume. So there are a diagram. Solid, when solid turns into gas, turns into when solid turns into liquid, it is called melting. When liquid reversely turns into solid, then it is called solidification. When liquid turns into gas, it is called boiling or evaporation. Boiling or evaporation. When gas turns into reversely liquid, then it is condensation. When a solid directly turns into gas, it is called sublimation. When a gas reversely or oppositely turns into solid directly, then it is called deposition. Melting, let's recall. Melting is a change of state from solid to liquid. Melting occurs at fixed temperature. This temperature is known as melting point of the substance. Melting point of water is 0 degree Celsius or 273 Kelvin. Definition. The melting point is the temperature at which a solid is converted to liquid at normal atmospheric pressure. A more specific definition of melting point. So melting point is the temperature at which the solid and the liquid phases are at equilibrium at a specific pressure, normally atmospheric pressure. So what is melting point? Definition. The temperature at which the liquid and solid phases exist in equilibrium without change in temperature is called melting point. Heat is required for the phase change, so heat can be added or removed without changing the temperature as long as matter is changing from solid to liquid or reverse. A melting point is also a function of atmospheric pressure. Freezing point. The temperature at which a liquid changes to a solid is called freezing point. Phase change graph for the water. So say solid ice, if we apply heat on it, then gradually increases its temperature, and when it reaches 0 degree Celsius, that means melting point, then solid and liquid, that means ice and water, remains in equilibrium state without changing its temperature. Then it turns into liquid. So boiling point. The boiling point is defined as the temperature at which the saturated pressure of a liquid is equal to the surrounding atmospheric pressure. Evaporation. Evaporation means simply vaporization from the surface of liquid. Vaporization of liquid below its boiling point is called evaporation. No boiling occurs, and the rate of vaporization depends on the diffusion of the vapor through the boundary layers above the liquid. So, what is the difference between boiling and evaporation? A process in which a liquid substance changes its state from liquid state to gaseous state by the application of temperature and pressure is known as boiling. Evaporation is the process whereby the water changes into vapor without boiling. Boiling is a quick process. Evaporation is a slow and steady process. Boiling, bubbles are formed. In evaporation, no bubbles formed. Boiling occurs throughout the liquid. Evaporation takes place only from the exposed surface of the liquid. Boiling occurs at a definite temperature is known as boiling point. Evaporation occurs at all temperature. Boiling, source of energy needed. In evaporation, energy supplied by the surroundings. So difference between evaporation and boiling. So evaporation always occurs at fixed or any temperature. Boiling can occur at a certain temperature, fixed temperature. Sorry. Triple point. Triple point. The particular temperature and pressure at which the water remains at its three states, solid, liquid, and gas, is called the triple point of water. The temperature of the triple point water considered to 273 Kelvin. 273 Kelvin. Now, latent heat, the amount of heat required to convert the substances from one state to another state without changing its temperature is called latent heat. So latent heat means hidden. Latent means hidden. So the amount of heat required needed to convert the substance from one state to another state without changing its temperature is called latent heat. So here ice converts into water and water converts into gas. Latent heat of fusion. Fusion means melting. The amount of heat required to transform the solid into liquid without changing its temperature is called latent heat of fusion. Latent heat of vaporization. The amount of heat required to convert the liquid into vapor state without changing its temperature is called latent heat of vaporization. Heat capacity or thermal capacity. So thermal capacity or heat capacity of an object is the amount of heat required to rise the temperature of the body 1 degree Celsius or 1 Kelvin. It is denoted by C. C equals to amount of heat energy required to rise the temperature T. So unit is joule per degree Celsius or joule per Kelvin. Joule per Kelvin. On the other hand, specific heat capacity, the amount of heat energy required to rise the temperature of unit mass of a substance by 1 degree Celsius or 1 Kelvin. It is denoted by also C. So C equals to Q divided by M delta T. M delta T, change in temperature. Unit joule per kg degree Celsius or joule per kg Kelvin. So specific heat capacity refers to the heat required by a unit mass of a substance to rise the temperature 1 degree Kelvin or 1 degree Celsius or of a material. Thermal capacity. So thermal capacity, the amount of heat energy required to rise the temperature of a body through 1 Kelvin is called the heat capacity of that body. Heat capacity depends on the material and the mass of the body. So heat capacity is C equals to Q divided by delta theta or delta T. Specific heat capacity, the amount of heat energy required to rise the temperature of a body of mass 1 kg through 1 Kelvin is called specific heat of the material of that body. So mathematically we can express S equal to Q divided by M delta theta. Joule per kg per Kelvin is the unit. So specific heat of lead is 130 joule per kg per Kelvin, means 130 joule of heat energy is required to rise the temperature of 1 kg of lead through 1 Kelvin. Calculating thermal energy changes. The equation is shown in the below. Q equals to M. M is the mass. C is the specific heat capacity, and here change in temperature, final temperature minus initial temperature. Energy transfer formula triangle relation. Energy transfer equal to mass in kg, temperature change in degree Celsius or Kelvin, specific heat capacity. What is calorimetry? The act or science of measuring change in the state variable of a body in order to calculate the heat transfer associated with changes of its state, such as physical change or phase transition under a specific condition, is known as calorimetry. Calorimetry performed with help of calorimeter. Calorimeter principle or principle of calorimetry. When two bodies of different temperature, preferably a solid and a liquid, are placed in a physical contact with each other, the heat is transferred from the body with higher temperature to a body with lower temperature until the thermal equilibrium is attained between them. The body at high temperature releases heat while the body at lower temperature absorbs heat. The principle of calorimetry indicates the law of conservation of energy. That is, the total heat lost by the hot body is equal to the total heat gain by the cold body. Remember, so if heat loss equal to heat gain. A 500 gram sample of water is heated from 10 degrees Celsius to 90 degrees Celsius. Calculate the amount of heat energy absorbed in kilojoules by the water. We know Q equal to ms delta T. Here m is the mass, s is the specific heat capacity, and delta T is the change in temperature. Here mass 500 gram and specific heat capacity for water 4.184 joule per gram per degree Celsius. Here change in temperature 90 degrees Celsius is the final temperature and 10 degrees Celsius is the initial temperature. So 90 minus 10, so 80 degrees Celsius. So by using the above formula, Q equal to 500 gram into 4.184 joule per gram per degree Celsius and 80 degrees Celsius. So Celsius cancel, gram cancel. So 1,67,360 joule. So 167.4 kilojoule. Calorimetry 250 kg say 0.250, that means 250 gram piece of iron at 95 degrees Celsius is dropped into 0.250 kg piece of iron at 95 degrees Celsius is dropped into 0.5122 kg of water at 18 degrees Celsius. What is the final equilibrium temperature? According to the principle of calorimetry, heat loss equal to heat gain. M1 C1 delta T1 equal to M2 C2 delta T2. Here heat lost by the iron, piece of iron. So mass of iron is 0.250 and Specific heat capacity of iron 450 and temperature difference 95. Let the final temperature be capital T. So 95 minus T equal to 0.512 kg into 4186 into T minus 18. So after calculation we get 21.845 degrees Celsius or 21.8 degrees Celsius. A solid has a definite shape due to its consisting of closely packed molecules which cannot move in between each other. When solid is heated to become a liquid, the molecules can move in between each other. However, the molecules remain spaced close together, and so liquid is as dense as and incompressible as liquid as solid. When a liquid becomes gas, the molecules fill up the space available. A gas is there, therefore is compressed, easily compressed. Molecular movement in gases. A gas consists of molecules moving about in random motion. So due to a collision, the speed and direction of each molecule is continually changing in unpredictable way. Brownian motion. In 1827, Robert Brown observed through a microscope the motion of the pollen grain suspended in water. The yellow sphere represents the pollen grain of smoke particle, and black particle represent the water or air molecules. The grains were seen to jerk about randomly. The similar observation can be seen with smoke particles suspended in air. So this experiment shows the presence of water or air molecules. Observing Brownian motion with smoke. Significance of the Brownian motion. Einstein in 1905 proved mathematically that the motion of the smaller invisible air particle must be as random as the larger visible smoke particles. The smoke particles move much more slowly than the air molecules due to their much greater mass. Gas pressure. The particle theory of the gas pressure explain gas pressure in the following way. Gas molecules in constant random motion. When a molecule collides with surface, it exerts a force on the surface as it changes its direction. The pressure exerted by the gas is equal to the total force exerted by the molecules over an area of the surface divided by the